Welcome to this tutorial. In this video, we'll explore the interface and available tools that allow you to modify existing components to match your truss design requirements. Let's get started. Before we begin modifying a component, let's first familiarize ourselves with the interface. Understanding how the software works will make the process much smoother. On the left sidebar, you'll find two buttons for Layout and Design. Today, we'll focus on Design mode, while Layout mode is covered in a separate video. For more details, be sure to visit our YouTube channel or refer to the documentation. The Truss Explorer subpanel displays all of your components with color-coded status indicators. Green means the analysis has passed, blue indicates the component hasn't been analyzed yet, and red signifies check exceeded. You may also notice this icon. If it's present, it means the component is linked in the layout. To confirm, hover over the component here, and it will highlight in green. If the icon is missing, the component exists only in the Truss Explorer subpanel and is not part of the layout. To delete a component, right-click on it and select Delete, or simply press Delete key. Keep in mind that this action cannot be undone, so be sure before removing a component. There are also additional options available here which we'll cover shortly. If you need to unlink a component from the layout, right-click on it, select Linked Envelopes, and the software will automatically switch to layout mode. Then right-click the component in the layout and choose Unlink, or simply click this button. Once unlinked, the icon will disappear, confirming that the component is no longer part of the layout. Now, let's modify this component according to your design plan. Moving to the right sidebar, you'll find a list of all possible items that can be included in your component. Clicking on this button will expand the category, revealing the full list. Selecting an item will highlight it in the scene, making it easier to locate. If you need to add an item, simply right-click on it and choose Add. For example, let's add a manual load. A settings window will appear, allowing you to configure the load details. Let's say we want to apply a uniform load along half of the bottom chord. Change the insertion method to Select Member and choose B2. Next, set the load magnitude to 10 PLF, leaving all other settings unchanged. Click Add, then Insert. To verify that the load has been inserted, click on this button again and check under this section. You'll see that it has been successfully added. To confirm visually, let's reanalyze the component. Select any of the load cases here, and you'll see that the load is applied to B2. Next, we'll remove all webs, leaving only the top and bottom chords. To add a member, use any of the launch methods discussed in the previous video and select Member. For example, you can right-click anywhere on the scene and choose Member. Once the member insertion window appears, all reference lines become visible on the scene, and we will be greeted with different insertion methods available. So let's go through each one. The first method is point-to-point insertion. Simply select 2 points in the scene, and the software will place the member accordingly. By default, members are inserted centered on the line and as a web member, so be sure to adjust these afterwards. Next, we have point slope insertion. Start by selecting a point, then hover your mouse over an area where it doesn't snap to an intersection. You'll see the angle and slope displayed. If you need a precise angle or slope, add the member first, then go to Advanced Settings. Scroll down and adjust the direction value to set the exact slope or degree. For example, 30 degrees. If you need to offset a member, you can do so here. Simply enter the offset value, and the member will shift accordingly. The third method is parallel member insertion. To use this, click on any reference line in the scene. Then, move your cursor to the desired offset distance. A snapping window will also appear, allowing you for refined snapping. If you want to change the offset distance manually, just go again to the Advanced options and change this field accordingly. Next is perpendicular member insertion. First, click on the reference line where you want the member to be perpendicular. Then, select a point that aligns with the center line of the member you want to insert. Now the member is added perpendicular to this member. Finally, we have division member insertion. click on two reference lines, and the software will automatically place a member at the midpoint, which is the default. If you need a different division factor, go to the Advanced Settings and adjust this field. For example, if you want to divide the space into 3 equal sections, enter 0.333. Note that only one member will be placed at a time, positioned closer to the first selected reference line. Next, I'll show you how to trim or cut member ends. First, select the member you want to cut, hold Shift on your keyboard, and then select the reference line where the cut should be made. Let's try extending this vertical web. As you can see, it didn't cut as expected. If we look closely, we'll notice that it's already cut to 2 reference lines. Simply click on any of the currently selected reference line again to unselect one reference line. And now you can cut it to this new reference line. Take note, you can always cut member ends against multiple lines. This can be used if you want to double cut a member against another member. The software will try to determine which end you want to cut. But if you need to specify an exact end, click the member again, go here, then click Add on the specific ends where you want to add it. Now let's add a bottom chord here. Make this a bottom chord and change its location to above the line. Next, we'll delete this existing bottom chord and trim the ends of these members. But what if you need to add a member where no existing reference line is available? Simply right-click on the screen, select Reference, and insert a new reference line. The insertion method for reference lines follows the same principles as adding members. So if you need to place a reference line exactly 2 feet from another, you can use the parallel insertion method. Now that we've covered all insertion methods, let's finish modifying and adding members to this component. Next, let's look at load settings, analysis settings, and material settings for this component. Click this button and you'll see these options. Be careful not to click this Other Settings button, as it will apply changes to the entire job. In this case, we are only modifying the settings for this specific component. You can configure different load values for roof and wind conditions. If needed, you can also add drag loads by selecting this checkbox and entering the necessary values. Adjust the roof load to 20, 15, and 5. Set the wind speed to 115 and save the changes. In the analysis settings, all analysis-related configurations are summarized here. While we're here, let's set the camber to 0. For material settings, you can specify the size, grade, species, and plate type for the lumber used in this component. Currently, the plates are set to any plate. The Paragon Any Plate refers to a plate with aggregated design values, meaning the final product can be selected from a specified list of plate types, as shown in here. To make further edits, click Edit Truss and use the available tools to customize the design. For example, if you want to add a wedge or slider, simply click Adjust Heel and choose which ends to modify. Now that we have finished editing this component, let's move on to the analysis. The result showed that the truss exceeded the design limits. To diagnose the issue, check the same lists here to identify any members or plates that are over capacity, or use the scene's visualization colors to locate problem areas. In this case, the middle section appears to be the issue, so let's add a K-web in this area. Next, place a bearing at this end by right-clicking on the scene and select Bearing. Also, ensure there are no gaps or overlaps when trimming or cutting member ends, as this can cause issues during analysis, as seen in this case. Let's carefully check everything. Once everything looks good, reanalyze the component, and it now successfully passes the analysis. If you want to review the analysis history, click this button to view previous results. For more detailed lists, reanalyze the component, but this time let's change it to detailed. Now all comprehensive engineering data and visuals for this component are accessible. That wraps up this tutorial. I hope you found it helpful and learned a lot from this video. See you on the next one.